Okay, hello everyone. This is our class 5, and as I told you, we are meeting every week. So this is week 5 lecture. So in this lecture, we are going to solve some of the problem. So this is one of the problem. Problem number 1. Problem given that for the beam for the element shown below. Okay, this is the element. Find the interpolating polynomial for each node and provide the value of polynomial. Okay, let us point P in each case. Filled dots represent nodes. So these are the nodes. Okay, so these are the nodes. Nodes 1, nodes 2, node 3. Similarly for this figure also, node 1, node 2, node 3, node 4. So node number given in clockwise direction like this. This is anti-clockwise direction. So this is our node numbering. Similar for this figure C also, anti-clockwise 1, 2, 3, 1, 2, 3. So these are the 4 element, and for these element we have to find the interpolating polynomial. Okay. So what is a use node numbering sequence as given in the diagram. So whatever numbering they are giving here, these numbering like node 1, node 2, node 3. Similarly for figure B, node 1, node 2, node 3, node 4. So these are going anti-clockwise direction like this. So we don't have to change these node numbering. We have to follow these node numbering as it is. Okay. So here given that each node having coordinate. So these are the coordinate. So I will write here node coordinate nodes coordinate, and this one also these are the nodes coordinates. For example, for this triangular element, we are having 3 node 1, node 2, node 3, and we have to find the interpolating polynomial for this triangular element. Okay, so now we are going to solve this problem. So first we will write coordinate matrix. So how we are going to write like this? Like for this element, it will be C. Okay, C 1 1 1 x1 x2 x3 y1 y2 y3. This is our coordinate matrix. This is our coordinate matrix. Okay. So what is give from this figure? From this figure, what we can say that whatever x1 x2 value. So here x1 will be 1, y1 will be 1, then x2 equal to 4, y2 equal to 0, then x3 equal to 4, then y3 equal to 3. So these are our coordinate for this figure 8 triangular element. Okay. Okay, so as I told you, so we are going to write here. So given that x1 equal to n, y1 equal to 1, x2 equal to 2, x2 equal to 4. This will be 4, y2 equal to 0, then x3 and y3. So here given that x3 equal to 4, y3 equal to 3. 4, 3. So these are the coordinates. Now these coordinates we are going to put in this to form this matrix, to form the coordinate matrix. So this will be 1, x1, x2, by x3, y1, y2, y3. Okay, so these are the coordinate. So this is our coordinate matrix. Fine. Okay. So now we are going to write the interpolating polynomial. We know that for trigonal element, we are going to write interpolating element like this: n x comma by x comma by means this is 2D element equal to 1 by determinant of for coordinate matrix, then ai plus bi x plus ci by. So what it means ai? AI will be ni. And ai means, for example, I equal to 1. For example, uh, for example, I will take black pen. For example, if I equal to 1, it means that n1 x comma y equal to 1 determinant 1 by determinant c, then a1 plus b1x plus c1 y. Okay, then what is the a1 a1 b1 c1 that we have to calculate. So a1, given that a1 equal to x2 by 3 minus x3 by 2. Okay, right? Then similarly for a2, what will be a2? a2 equal to a2 equal to x3 by 1 minus x1 by 3. Then a3 equal to x1 by 2 minus x2 by 1. Right? So in general, how we can write? In general, what we can write? In general, like this we can write ai equal to xj by k minus xk by j. For example, for this element, triangular element, we are having 1, 2, 3. So this is our I, j, k. So if we are going to write for a1, if we are going to write for a1 means I equal to 1. So then a1 equal to xj means x2, yk means by 3, then xk means x3, then by 2. Okay, so like this we are going to write for all the a1, a2, a3. So we will got a1, a2, a3. Then what is b? B means bi means just differentiate between that y coordinate. So if I will say b1 equal to, so I will say b1 equal to by 2 minus by 3. So in general, how we can write bi equal to xj minus by k. Okay, and this is for a. This is for ai. Similarly, what is ci? Ci means c1. C1 equal to minus x2 minus x3. Okay. Then what is c2? C2 equal to minus x3 minus x1. What is c3? C3 equal to minus x1 minus x2. So in general, how we can write this is our xi. Fine. So by following this, so this is our a1, a2, a3. Then what is b2? This is our b1. Then b2 equal to by 3 minus by 1. Then b3 equal to uh, b3 equal to by 1 minus by 2. Okay, so we got all these that coefficient values. So this is our ai or a1, a2, a3. Then this is our b1, b2, b3, and this is our c1, c2, c3. So like this, we will get all the coefficient to get the interpolating function or shape function for this triangular element. Okay. So for example, I want to calculate n1. I want to calculate n1. So n1 means I equal to 1. Okay. So n1 means here n1 means we have to put I equal to 1. So if we will put I equal to 1 in this equation, what we will get? N1 equal to determinant of matrix C A1 B1 C1, then A1 B1x C1y. Okay. So let's calculate A1. So we are going to calculate A1. So what we will get A1? So I will write here A1 equal to, by using this formula, A1 equal to x2 by 3. X2 by 3. So let me write those x. Okay, we will write here. So A1 equal to x2 by 3 minus x3 by 2. So A1 equal to, what is x2? X2 we are having 4. What is by 3? This is 3. It means 12 minus what is x3? X3 we are having 4. What is by 2? By 2 0. So it will be 12 only. Okay. So this will be 12. So we got A1 equal to 12. Right? Now similarly we are going to find A2. So 2.A2, as I told you, this is a equation for A2. We have to this equation to find A2. Okay. So what is our A2? A2 will be x3 by 1. So I will write here A2 equal to x3 by 1 minus x1 by 3. So I'm going to put the value. What is our x3? What is our x3? So this is our x3, we got 3. Sorry. X3 is 4. This is our 4. But in y1, we are having 1. So it will be 4 only. Then what is x1? We are getting 1. What is y3? We are having 3. So it will be 3. It means it will got 1. So we got A2 equal to 1. Similarly, A3 will be x1 by 2, x2 by 1. Okay, so like this we will get x1 by 2. So x1 by 2, this is 0. Okay, x2 by 1, x2 it will be 4. So A3 will be 4. So we got A1, A2, A3 all. And now we have to find V1. V1 means by 2 minus by 3. So we are having by 2 0, by 3 3, so minus 3. Okay. Then B2 equal to B3 minus Y1. So B3 minus Y1, 3 minus 1 equal to 2. What is Y1? What is B3? B3 Y1 minus Y2. Y1 minus Y2 it will be 1. So we got all these B1, B2, B3. And now I want to find C1, C2, C3. So I will take this space here. This is my domain. What is C1? C1 equal to minus x2 minus x3. I will write here. So x2 minus x3, we have x2 means 4, x3 is 4, 0 means 0. We will go to 0. Then what is C2? C2 will be x3 minus x1. So x3 is 4, x1 is 1. 4 minus 1, 3, and means minus 3. So we got C1 equal to 0, C2 equal to minus 3. And what is C3? C3 we got x1 minus x2. So x1 minus x1 is 1 minus 4 minus 3 minus 1 plus 3. It will be plus 3. So we got all these value. So A1, A2 we got. So I will write here A1 equal to 12. Then A2 equal to 1. A3 equal to 4. B1 equal to minus 3. B2 equal to 2. B3 equal to 1. C1 equal to 0. C2 equal to minus 3. C3 equal to 3. Okay, now we are going to put here. So we want to, for example, I'm going to find n1. So n1 means n1 equal to 1 by determinant C, A1 plus B1x plus C1 by. Okay, so first let's find the determinant of this matrix. So what will we see? So let me take one extra page here. So I will add one page and I will move this one here. Okay. So let me write here what is C matrix. We are having C matrix equal to 1 1 1 1 1 1 and 1 4 4 1 0 0 3. 1 4 4 1 0 1 0 3. Yes. So what will be determinant? How we are going to find this determinant? So determinant will be like this. We have to 1 4 into 3 minus 4 into 0 minus 1, then 3 minus 0 plus 1, 4 minus 4. So what will be our 12? Then this will be 0, this will minus 3, we will get 9. So we got determinant equal to 9. Fine. So now we are going to put here. So we got 1 by 9. A1 we are what we are A1 equal to 12. So 12 plus B1. We got our B1 it means what is our B1? B1 is minus 3 minus 3x. What is C1? C1 we got 0. So this will be our 0. So what will be in general 1 by 9 equal to 12 minus 3x. This will be our n1. Yeah, this is our. So what we can write in simplified form. So 12 by 9 means 4 by 3 minus x by 3. This will be our n1. Right? Fine. So now, for example, I want to find n1 at a specific value. For example, for a specific value at p equal to 3 comma 1. I want to find n1 at 3 comma 1. So this is our n1. N1 equal to 4 by 3 minus x by 3. This is a function of x. Let me write like this. So this is n1 function of x. And I want to find n1 at 3 comma 1. Okay. So I'm going to put here value 4 by 3. X we are having 3. 3 by 3. What we will got? 4 by 3 minus 1. It's mean that it will be 1 by 3. Okay. This will be 1 by 3. Similarly, we are going to find n2. So what will be m2? What will be our n2? N2 means n2 x comma y equal to determinant. Yes, determinant. Then a2 plus b2x plus c2 y. So determinant we got 9. Okay. What is a2? How much we got a2? A2 equal to a2 equal to we got a2 equal to 1, b2 equal to 2, c2 equal to minus 3. So we got a2 equal to 1, b2 equal to 2, c2 equal to minus 3. Okay. So this will be our n2. Okay. So if I will write in general form, what will be? It will be 1 by 9 plus 2 by 9 x minus y by 3. So this will be our n2. Fine. So now for example, I want to find n2 at 1 comma 3. Okay. So n2 at 1 comma 3. So I'm going to put x comma y equal x comma y 1 comma 3 1 by 9 we are having x equal to 1, so 2 by 9 minus 3 by 3. How much we got? This will be 11 by 9 minus 1 means 2 by 9. So this will be our n2 at 1 comma 3. Similarly, what will be our n3? So we are going to find n3 x comma y equal to, similar formula we are going to use, determinant c, then a3 plus b3x plus c3y. Fine. And now, as I told you, what is our a3, b3, c3? So we already calculated a3, b3, c3. So a3 equal to 4. This is our a3 equal to 4, and b3 equal to 1, and c3 equal to 3. So 4, 1, 3. So a3 equal to 4, b3 equal to 1, c3 equal to 4, 1, 3. Okay. Yeah, right. A3 4, b3 1, c3 equal to 3. Okay. So now we are going to put these value here in this problem or this equation. So what will be our n3? N3 will become x comma y equal to determinant c, a3 4, b3 1, c3 3y. Okay. And as I told you, this is we are having 9, so I will put here 9 instead of determinant. This will be our n3. So in general, how we can write 4 by 9 plus x by 9 plus y by 3. This will be your n3 x. And what will be n3 at 1 comma 3? So we are going to put 1 comma 3 equal to 4 by 9, 1 by 9, 3 by 3. It will be 13 by 9 plus 1 means 22 by 9. This will be your n3, and this will be your n2, and n1 we already calculate. So this is our first answer. So this three node element. So this one be solved. Okay. Similar procedure we are going to follow for this B, C, and D element. This is 4 node element. This is 6 node element. This is 8 node element. Okay. So let's go for second problem. So what first I want to summarize here. First what we did. First we calculated that coordinate matrix. Okay, C is the coordinate matrix. Then we wrote that interpolating polynomial. This is our interpolating polynomial. So we wrote in general ni equal to ni x comma y equal to 1 by x, 1 by c, ai plus bix plus ciy. Then we calculate a1, a2, a3 because we are having 3 node only. So we are going to calculate a1, a2, a3. Similarly, we calculated b1, b2, b3 and c1, c2, c3. Okay. After obtaining all these 9 coefficient, we put it in this equation. For example, I want to find n1. So I will be replaced by 1. So it will be a1 plus b1x plus c1y. Okay. Then we obtained n1. Then n2 similarly a2, n2 equal to n2 x comma y equal to 1 by determinant c, a2 plus b2 cy plus c2 y. Then we put out these values and we got this into equation. We also calculate this determinant of c to calculate this our interpolating polynomial. Then similarly we follow okay. So for example, this is our n2, and for a particular location, a particular point, for example, I will say n2x 0, 0. So we are going to put 0, 0 here. So this will be 1 by 9 only. Okay. And similarly, we retain formula for this n3. This is our n3. N3 equal to a3 plus b3x plus c3y. This is the n3. And we also obtained n3 at 1 comma 3. This is our n3 at 1 comma 3. So like this, we followed this procedure and we obtained these all the shape function. Or I will say this is also called as what we call interpolating polynomial. Okay. So now we are going to follow same procedure for this second element. This is 4-node element. So what we are going to do, what we have to do, similarly we have to find C matrix. Okay. Then we need to find the determinant of C matrix. Then we are going to write that inter uh, this interpolating polynomial equation. Then we are going to fill that a1, a2, a3, a4 because we are having 4 node here. So we are going to find a1, a2, a3, a4. Similarly, v1, v2, v3, and other coefficient also. So let us start. So this is our 4-node element. So I will write here. This is our 4-node element. Node 1, 2, 3, 4. Okay. And it is having 0, 0, 5, 1, 4, 3, 1, 3. I will throw in same as given in the question in the problem. So this will be like this. This is 0, 0. Okay. Then 5, 1, 4, 3. So 5, 1, 4, 3. And this one 1, 3. This is 1, 3. Okay. So what is node? This is node number 1, node 2, node 3, node 4. Okay. So what will be coordinate matrix for this 4-node element? This is our coordinate matrix 1, 1, 1, x1, x2, x3 by 3, y1 by 2 by 3, and x1, y1, x2 by 3. This is our coordinate matrix. Okay. Now we are going to find that coordinate matrix. So let's go here. So this is our coordinate matrix. C equal to this is our, I will write here, C equal to 1, 1, 1, 1, x1, x2, x3, x4, y1 by 2 by 3 by 4. Then x1 by 1, x1 by 1, x2 by 2, x3 by 3, x4 by 4. Okay. This is our coordinate matrix. Okay. So now we are going to fill this value. So after putting these all the coefficient value x1 by 1, x3 by 3, all the coefficient we will got like this. Then the interpolating polynomial given for this polynomial like this. This is already predefined formula. So please go through all the video. You will get how we are going to obtain these interpolating polynomial. So this is interpolating polynomial. And by putting this value, we will get this equation. So in the point at P, they are saying at point P comma 2 comma T. So we have to find P comma at 2 comma T. So when we are going to put 2 comma 2 here. So this will be, for example, I'm going to put here. So what we will get? 2 means 4 by 15 minus 2 by 3 minus 2 by 5 plus 1. So it will be like this: 15, 4, 10, 6 plus 1. So this will be what we will got. This will be 15 also. So this will be 1690. So for example, like 15, 4, 10, 6, 15. Correct only, no? So we are getting 10, 19 minus 16 by 15. It will be 3 by 15. So we will get 1 by 5. So like this we will get. And for this second element also. So this is second element. 1 minute. So this is our second element. So if I want to put 2 comma 2, so it will be 6 by 10 minus 4 by 10 means 2 by 10 equal to 1 by 5. This is for similar third element and fourth element. So we will get all the coefficient value. Okay, all the element value for this interpolation. Similarly, for example, now we are going to solve this for C node also. This is for this 6 node triangular element. Okay, this is one node 1, 2, 3, 4, 5, 6. It is having 6 node. And similarly, we are going to solve. So first, we are going to find that coordinate matrix. So just I want to request you, if you are, it will be very hectic if you are doing manually. So just use MATLAB or any other software to do these calculation, because if you are doing manually, like there is a very high chance for any error. Okay. So now, for example, this is C matrix for this 6 node element. Okay, this is very big matrix. It is having 1, 2, 3, 4, 5, 6, 6 by 6. Okay, this is 6 by 6 element with that matrix. And similarly, we are going to use this equation to get the interpolating polynomial. Okay, so now for this 6 node triangular element, this will be our n1, this is our n2, n3, n4, n5, n6. So we are having 6 nodes. We will have 6 interpolating polynomial, or I will say we will have 6 shape function. For example, I am having only 2 node element. So this node 1, node 2, node 1, node 2. So I will get only 2 interpolating polynomial, n1 or n2. For example, I am having n number of node. So I will get n number of interpolating polynomial, or I will say shape function. Okay, or shape function also we are calling. So this will be our n1, n2, n1, n2, n3, n4, n5, n6. And for example, I want to find n1, n2, n3 at 2, 1. So 2, 1. I want to find at 2, 1. So what will you at 2, 1? So we are going to put here 1. So this will 0. If you are going to put 2, 1 here, you will get 1 0.008. Okay. So let's for 1 we are going to verify. So we are having n1 equal to 2, 1. So this will be 4 0.08 into 1 plus 0.16 equal to minus 0.6 into 2 plus 0.08 into 4 minus 0.6 into 2 plus 1. So this will be 0.08, then plus 0.32 minus 1.2 plus 0.32 minus 1.2 plus 1. So then these two will be, or let's going to add. So this will be 0.4 minus 2.4 plus 1.32. Then what we will get here, c minus 2 plus 1.32. This will be 8. This will be 6 minus 0.68. I did something wrong here. So just verify, because if we are doing manually, there are high chance of any error. Okay. 1.32. Something I missed here. So similarly for N2, N3, N4, N5 also you can get. Okay, then we are coming for this uh, last problem. We have to find we have to find interpolating polynomial at 0, 0, 0.5, 0.5. So this is D. This figure, this is having 9 node element. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So same also we are going to write for here. This is our coordinate matrix. This is our coordinate matrix for 9 node element. Okay, and this will be our interpolating polynomial. So after putting this value, if you are going to if you are going to do manually, definitely you will get some error. So I just request you please go use some tools like MATLAB, Python, whatever you are suitable with that one. So you can use. So you are going to if you multiply manually anyway you cannot do. So this will be our n1, n2, n3, n4. We are having 9 nodes, so we will get 9 in that element, n5, n6, 7, 8, and 9. And in all these 9 elements, for example, I want to find all these shape function or interpolating polynomial at 0.5, 0.5. So we have to put x equal to 0.5, y equal to 0.5 in all the equation. Then you will get all these values. Okay. So like this, we are going to solve the, we are going to find the interpolating polynomial for the problem. These are a little bit, I will say, lengthy questions. But if you are going to write some code or you are going to use some tools, it will be very easy to solve. Or for like simple problem, you can do manually, like for this triangular element. But if you are going for like a higher number of nodes, it will not be easy to solve by hand. So I just request you go use some tools to solve this problem. Okay. So I think then for now next question what we are going to solve this question, simple question. State of stress for the plane strain problem is given by, we all know this is our plane strain condition. Sigma xx, sigma yy, sigma zz, and sigma xy. This will be our plane strain condition. In whatever third question, in which of the following is an appropriate idealization for modeling cantilever beam transfer loader with uniform top surface? Okay, so this will be also plane stress. And fourth question, for a four node element of 2D elasticity problem, displacement field of form given by this equation should not be chosen because it violates geometric isotopic condition. This you will go through video, you will get what meaning of geometry isotopic condition. Okay, so now we are going to solve this problem by using MATLAB. So first we will write here clear for CLC. Then we will save one problem like interpolating polynomial. Okay, so for this trigonal element we are going to solve. So given that x1 equal to 1, y1 equal to 1, then x2 equal to 4, then by2 equal to 0, then x3 equal to 4, y3 equal to 3. These are the coordinates that are given for the trigonal element. These are our given coordinate. And I'm putting here semicolon because I don't want to print these value here. For example, if I'm going to run this one, so we will not see these value in command window. Let's see. Okay, so we are seeing in workspace, but we are not seeing in command window. For example, if I want to see these value in command window, so I will just remove this semicolon. Then all these value along with workspace, it will show in the command window. So okay, so see, we are getting by1, by2, by3. Okay, and just we will keep same. And clear all means whatever we are having workspace command window, it will clear all. Okay, so for example, we want to run in section wise. Like if I'm going to run here section wise, so run section. It means it will this section I'm going to run. 1 minute. So for example, I want to run this section. Okay, this section. So it will clear everything here. So run section. See, everything going. Command window also, workspace also. If I'm going to run for next section, so you have to use these 2% sign to differentiate between two sections. So if I will run, it will come here. Okay, so like this, we are going to. These are the command in MATLAB. So we have a coordinate and we are having p means p equal to 3 comma, so 3 comma 1. It is having some error, so we will write here. First we will write here symbolic x and y, then p. Okay, we will write first, then we will write later. So now we are going to write this our coordinate matrix. So I will write coordinate matrix. Okay, so what we are having c equal to, this is matrix of 3 by 3. So we are having 1 comma x1 comma y1. Comma means for row. Then we are going for second. Comma means column. We are going for second row. So semicolon. Then 1 comma x2 comma y2. Then semicolon 1 comma x3. Okay, comma y3. So this will be our coordinate matrix. Okay, this is our coordinate matrix in capital C. Okay, so I want to find determinant. So I will write here data of C equal to we are going to write here C. Let's see. Is it okay? Symbolic. So if you are having any issue, we will open Chrome and we will search symbolic how to write symbolic of MATLAB. So you will get this command. So syms. Also I missed something. Syms. S by MS. MS. Okay, one more thing. How to find determinant in MATLAB. So we have to write that. Yeah, we were writing correct only. So let's now we are going to run. Let's see what we are getting C. So I just will print C. We want to see C value. So we are getting 9. Yeah, we also got 9. So we are getting 9. Okay. Now now we want to find N1, N2, and N3. So what will be our N1? N1 equal to 1 by that C, okay, into A1 plus B1 into X plus C1 into Y. Okay, but we don't know A1, A2, A1, B1, C1. So we will write here interpolating coefficient. Okay, so we will find A1. A1 means A1 equal to x2 by 3. So x2 into by 3 minus x3 into by 2. This will be our A1. And what will be our B1? B1 equal to by 2 minus by 3. And what is our C1? C1 equal to minus x2 minus x3. This will be our C1. So similarly, we have to find that. So I will, okay. Now, after putting these value, what we will get here? N1 x comma y. Let's go into run how hard we are getting. C8. Oh, that C will be. This will be multiply by. Yes. So now we want to find N1 at N1 at 3 comma 1. So I will write here 3 comma 1 and I will print. I want to see how much we are getting. Yes, so this is we are getting this is how much we got here. 4 by 3 minus x by 3. Yes. And if I will check here in full screen, this is what N1. This is 3